Welcome to this comprehensive guide on sorting and filtering game data within Unity and Visual Studio, tailored specifically for beginners. Efficient data management is crucial for creating responsive and engaging games, allowing players to interact with dynamic information seamlessly. We'll explore fundamental C# concepts and their practical application within the Unity 3D engine, ensuring you grasp both theory and implementation. Understanding your game's data structure is the first step. This includes player inventories, enemy stats, or quest logs. Sorting helps organize this data in a meaningful order, such as by name, score, or rarity, enhancing user experience. Filtering, on the other hand, allows you to display only relevant information, like active quests or items of a specific type. Let's begin by setting up a basic Unity project and creating a simple C# script to hold our game data. We'll define a custom class to represent our game items, including properties like name, ID, and value. This structured approach ensures consistency and makes data manipulation much easier as your project grows. For storing multiple items, we'll use a list of our custom class, which is highly flexible and dynamic. Arrays are also an option, but lists offer more convenience for adding and removing elements during runtime. Now, let's populate our list with some sample game data to work with, simulating a small inventory. The simplest way to sort a list of basic types is using the list sort method directly. However, for custom objects, we need to tell C# how to compare them. One way is to implement the iComparable T interface within our GameItem class. This allows us to define a default sorting behavior for our items, for instance, by their unique ID. Another powerful method is using iComparer-T, which provides more flexibility for different sorting criteria. We can create multiple iComparer implementations to sort by name, value, or any other property. To use an iComparer, simply pass an instance of it to the list sort method. For sorting by multiple criteria, links order by and then by methods are incredibly useful. This allows you to define a primary sort key and then secondary keys for items with the same primary value. Now, let's move on to filtering data, which is essential for dynamic displays and search functionalities. The simplest way to filter is using links or a clause, which takes a predicate function. This predicate is a condition that each item must meet to be included in the filtered result. You can combine multiple conditions using logical operators like and, or for more complex filtering. For example, finding all rare items that are also weapons requires combining these conditions. Filtering can also be case-insensitive by converting strings to lowercase before comparison. Now, let's see how to display our sorted and filtered data within the Unity UI. We'll create a simple UI panel with text elements to represent each game item. A dedicated script will be responsible for updating these UI elements based on our sorted or filtered list. This involves iterating through the processed data and assigning values to the respective UI components. For real-time interaction, we can add input fields or drop-downs to trigger sorting and filtering. When a user types into a search bar, our filtering logic can be reapplied instantly. Similarly, selecting an option from a drop-down can resort the data based on the chosen criterion. Remember to call your UI update function after every sort or filter operation to refresh the display. A helpful tip: encapsulate your sorting and filtering logic into separate, reusable methods. This makes your code cleaner, easier to maintain, and less prone to errors. Another tip: for very large datasets, consider using pagination or incremental loading to avoid performance bottlenecks. Repeatedly sorting or filtering massive lists can impact frame rates, especially on less powerful devices. Always profile your game to identify and optimize any performance-heavy operations. For complex filtering, consider using a dedicated search algorithm or data structure like a tree for string matching. This can significantly speed up searches in large text-based datasets. Remember to handle edge cases, such as empty lists or null values, to prevent runtime errors. Robust error handling ensures your game remains stable and provides a smooth experience. Best practice: use scriptable objects in Unity to store your game data. This allows you to create and manage data assets directly within the Unity editor, separate from your code. It promotes a cleaner architecture and makes it easier for designers to populate game content. Another best practice is to use enums for defining categories or types of items. Enums provide type safety and make your code more readable and less error-prone than magic strings. Consider using a data-driven approach where sorting and filtering rules are configurable. This allows for easier adjustments and balancing without modifying core logic. Regularly refactor your data management code to keep it optimized and understandable. A well-structured code base is a joy to work with and scales much better. In summary, we've covered the essentials of sorting and filtering game data using C# in Visual Studio and integrating it with Unity. You now have the foundational knowledge to manage dynamic data effectively in your game projects. Experiment with different sorting criteria and filtering conditions to see their impact. Practice is key to mastering these techniques and applying them creatively. Consider building a small project that heavily relies on sorting and filtering to solidify your understanding. Thank you for joining this tutorial. We hope it empowers you to create more dynamic and engaging game experiences. Keep exploring, keep coding, and have fun building your next great game.